MRI, magnetic resonance imaging. A technique using an electromagnetic field and radio frequencies instead of an X-ray to visualize the human anatomy. Its magnetic strength is several thousand times more powerful than an ordinary magnet. Please keep in mind that this magnetic strength is 10 times stronger than the Earth's gravitational pull. To demonstrate its power, we'll try bringing a ferromagnetic metal object susceptible to magnetic fields near the MRI gantry. Next, a lightweight ferromagnetic object. This powerful magnetic field is always on. Therefore, you should always take precautionary steps to prevent injury. Never bring ferromagnetic objects near the MRI system. This is the most important point to remember. We'll try another experiment, this time using a chain. As the chain nears the gantry, the magnetic force suddenly grows stronger about 1.5 meters away. This graph shows the increase in magnetic force per distance from the MRI gantry. The magnetic pull is hardly noticeable until about 1.5 meters away it grows irresistibly powerful. Within this zone, the magnetic pull increases exponentially as the object nears the gantry. The heavier the ferromagnetic object, the stronger the magnetic pull. Remember, the magnetic field is always on, even when the MRI system is not being used. Accidents can also easily occur during cleaning or maintenance, so establish a system of risk management and educate all cleaning and maintenance personnel. This is a 3D visualization of the force of the magnetic field. The exam room is shielded on a 5 Gauss safety line. Never bring ferromagnetic objects within the MRI room. Increasingly these days, MRI systems are being installed in smaller-sized rooms. Special care is needed within these smaller rooms where it is easy to enter the magnetic field inadvertently. Before entering the MRI room, the first thing you should do is check for ferromagnetic objects on your person. In your breast pocket, are there scissors or tweezers? A pen or pencil? A pen contains metal and can easily become a projectile. A nameplate or film badge may also contain metal, causing it to fly off and injure someone. The stethoscope did not respond to the industrial magnet outside the room, yet it responded to the powerful electromagnetic field. The bank or credit card in your wallet? While there's no danger of them going into the magnet, the information on the card can be erased. A mobile phone or electronic data storage device could also be rendered useless, so do not bring them into the room. Paper clips and hairpins need special attention. Because they are small, they often become lost when they fly into the unit and cause malfunctions. What about a watch? We'll try placing a clock near the gantry. The magnetic field stops the clock's hands. Left in the magnetic field, the clock will become magnetized and unusable. Carefully check your accessories and the contents of your pockets before entering the MRI room. Next, check the patient thoroughly. Earrings and body-piercing jewelry used on all parts of the body. Necklaces, watches, rings, bracelets, and other metallic items should be removed. Hairpins and hair clips are easily overlooked and need care. The metal clip hidden inside the hairpiece. Hearing aids. Most eyeglasses are generally non-magnetic, but be sure to check for ferromagnetic parts. Some objects that do not respond to an industrial magnet will respond to the powerful MRI magnetic field, so for safety's sake, instruct patients to remove all items from their person. What about pockets? A locker key in a pocket is easily forgotten. Don't forget hospital consultation cards and electronic money, which can be erased and rendered useless. Now, have we checked everything? Wait a minute. Does the patient have any ferromagnetic implants? Cardiac pacemakers will cease to function normally in the powerful magnetic field. Patients with pacemakers are forbidden from entering the MRI room. Surgically implanted clips and plates can move or become dislodged. Artificial limbs and joints also pose a danger, for they may be pulled by the magnetic force. Interview patients to confirm the absence of such devices before allowing them to enter the room. Besides the magnetic field, MRI poses another danger, that of heat generated by the radio frequency waves. Metallic substances, even if non-magnetic, can become hot and burn the patient. Remove any electrotherapy patches and disposable body warmers. Eyeshadow and eyeliner and even colored contact lenses often contain ferromagnetic material, so please remove these items before the examination. Tattoos may also cause burns. Metal can also affect the quality of clinical images. In this image of the head, the area indicated by the arrow is distorted. The cause? A hairpin. The cause here, dentures. Here, the artifact is caused by the patient's metal belt buckle. A bra or other undergarments may contain metal parts that can also distort images and hinder diagnosis. Check the patients thoroughly one more time and, for safety's sake, remove all metallic objects. What can you do to ensure the patient's safety and prevent accidents before they happen? First, pre-screen the patient for the presence of any magnetic or metallic objects by interviewing or using a checklist. Always provide a dressing room and locker for belongings outside the MRI room. Keep a portable metal detector within the MRI work area. Double-check the patient for metallic objects there before they enter the MRI room. Post warning signs in readily visible areas, so patients will be aware of the need to check themselves. Prepare special pre-checked medical implements that can be used inside the MRI room. Label them so they are instantly recognizable. Use only non-ferromagnetic intravenous drip needles. Next, the precautions you should take during the MRI exam. Burns may occur during the exam, even if the patients have no metal on their person. The cause? Electrocardiogram cords. If looped, the cord can grow hot from the high-frequency current. When connecting the electrodes, make sure the cords do not become looped. An RF coil cable may sometimes form a closed loop with the patient's body. Make sure the cable does not touch the patient. Parts of the patient's body may also form a closed loop, such as thighs, knees, ankles, arms and torso. Insert a non-conducting pad in places where the skin might touch and form a closed loop. How does one cope with an electrical power failure? During a power failure, the couch will no longer move automatically. Unlock the couch and pull the couch and the patient out by hand. Even if the electricity goes out, the powerful MRI magnetic field will remain active. Remember this fact when removing the patient. In the confusion of an emergency, make sure not to bring magnetic medical equipment into the MRI site. Many MRI-related accidents involving projectiles may occur at this time. Oxygen tanks, stretchers, and IV stands account for some 70% of the MRI-related accidents that have been reported. This is the proportion of people who have inadvertently brought ferromagnetic objects into the MRI room. Most accidents occur in the confusion of an emergency. Please always keep this fact in mind. Caution. Do not enter. A metallic object has been detected. Recently, more and more facilities are establishing flux gate sensors as a preventionary measure. If a projectile accident should occur, do not attempt to forcibly remove the projectile. This is extremely dangerous. The object may abruptly move and cause injury. Call your nearest service center immediately so that a secondary disaster does not occur. If by some chance a serious injury occurs, it may be necessary to turn off the magnetic field. Pushing the quench button of the superconducting magnet will produce a phenomena called a magnet quench. When the magnet loses superconductivity, it develops increasing electrical resistance. The result is increasing heat inside the magnet. The heat in the magnet causes the liquid helium used as a cooling agent to vaporize and erupt in the form of steam. This helium gas is normally vented outside the building through a special ventilation duct. The great volume of steam can be mistaken for a fire, so it is important to notify the hospital emergency information team and fire department. If the helium gas should leak into the room, where it can potentially lower the oxygen level of the air, an oxygen monitor will detect this abnormality and an alarm buzzer will sound. If a quench should occur while you are performing a study, immediately evacuate the patient from the MRI room. A powerful magnetic field continually surrounds the MRI system. With new technological advances, higher magnetic field strengths are being used to provide higher resolution images. Therefore, even very small objects pose extreme danger. I was in a hurry, or I forgot. Casual attitudes like these may lead to irreparable accidents. To protect the lives of patients and coworkers, conduct hospital training sessions regularly and whenever there are personnel changes. An earnest request from Toshiba Medical Systems.